For generations, the people of Massachusetts have operated as active stewards of a massive, living coastal tidal ecosystem. But the coastline is under severe, invisible pressure. Decades of habitat loss and modern nutrient runoff from housing developments are now choking the water column. This creates a difficult friction. We must restore these vulnerable waters, yet we cannot discard the livelihoods of the people who depend on them. Effective conservation must include human industry. In this landscape, the most resilient environmental solution is also a profitable one. This data maps the scale of the state's aquaculture industry, with Wellfleet serving as its center. The town manages 232 acres through 141 individual grant holders. The workforce density is high. Shellfishing employs roughly 10% of Wellfleet's entire year-round resident population. This model is expanding across the coast. Agreements like the Scituate-Cohasset Intermunicipal Partnership are now creating new frameworks for targeted, community-driven aquaculture. Farming the ocean is a centuries-old heritage, a foundation for the year-round financial stability these municipalities depend on. This anatomical diagram illustrates an oyster's bioextraction. These non-fed organisms grow solely by purifying the water column, drawing in microscopic particles and outputting clarified water. The metrics show a massive throughput. A single adult eastern oyster processes up to 163 liters, roughly 43 gallons, every day. This filtration is a defense against eutrophication. Nitrogen runoff from coastal developments trigger algal blooms that block sunlight and kill the eelgrass habitats other species need to survive. Research from Wacoit Bay quantifies the impact. Through tissue assimilation and burial, a restored reef or farm environment removes nearly 500 pounds of nitrogen per acre annually. The biological process turns a pollutant into a mechanism for restoring water clarity. Beyond the biology, the wire cages and floating gear used by farmers function as artificial reefs. Researchers at the NOAA Milford Lab used GoPro cameras to capture thousands of hours of wild fish interacting with aquaculture gear in New England waters. This chart shows aquaculture gear recorded 1.6 to 4.7 times higher fish abundance than sandy seafloors. Species like black sea bass and tautog use the crevices for shelter. Furthermore, behavioral evidence captured schooling, territorial defense, and courtship happening directly on the gear. In regions where natural rock reefs have been degraded, commercial aquaculture gear provides the three-dimensional architecture that wild marine life needs to thrive. The localized success of individual towns creates a significant statewide economic driver. This graphic visualizes a primary valuation of nearly $31 million in Massachusetts. Following the arrows down reveals a 1.79 economic multiplier. This farm revenue stimulates secondary markets like gear manufacturing and logistics, supporting over 2,000 local jobs across the supply chain. Maintaining this scale requires strict public health protocols, such as rapid cooling for Vibrio control. These regulations guarantee quality and safety for the consumers. The industry proves that high-resolution regulatory oversight and ecological restoration can yield sustained economic profitability. As we move through 2026, the Massachusetts aquaculture sector is entering a phase of institutional maturation. The industry is transitioning from pandemic-era volatility toward long-term stabilization. This blue economy represents a direct symbiosis. As these farmers become more prosperous, the coastal waters become cleaner. Those tending the water today are the frontline guardians of the shoreline. The oysters themselves and the dedicated farmers who work them are the living